Hi, everybody. I'm Manny, and as mentioned, I'm head of documentation at Skyflow, which is a data privacy vault company. What it means to be head of docs there is that I own everything that involves words that isn't marketing. That means error strings, error codes, all UI strings, all of the external documentation, all of the internal documentation, the API surface area, the SDK surface area, literally everything that involves words. But today, I'm going to talk to you about self-healing documentation systems. They're changing the way that we maintain API documentation, user documentation, developer portals. Imagine documentation systems that automatically detect and fix their own issues, staying accurate and reliable, even as your products rapidly evolve. We're going to start by talking about the current state of docs pipelines. Then we're going to dive into new suites of tools that power these autonomous or semi-autonomous systems and how each of these tools integrate with each other before wrapping up and discussing some of the possibilities that these advancements bring to us. So today's pipelines. In general, we've got a few categories of tools. We've got authoring tools, we've got publishing tools, and we've got collaboration tools. And all of these together are what make our teams go round. You don't want to be working without any of these groups. Now, in a CCMS, component content management system, or traditional CMS pipeline, these tools are going to be things like WYSIWYG editors for content creation. The publishing tools are going to be you generate PDFs or you generate HTML output and you distribute them in places like SharePoint. The collaboration tools are going to be SharePoint or Jira. This all might be managed in a big monolithic system like Adobe Experience Manager. This setup is something that people who are more familiar with DITA might experience or might be more familiar with. And in general, this is going to be what it looks like. You get in a doc request from Jira. You go into your CMS, you author whatever content you're going to deal with, and then you export out whatever formats you need and share it out however you need to your team and to your customers. In a docs as code pipeline, we have the same categories of tools. I say we, yes, I just outed myself. I do docs as code. I'm sure many of you in this room do too. And the tools here, they actually fit in the same buckets. They're just different tools. In fact, you could put GitHub into almost every one of these buckets. Because, great, we got a doc request, GitHub issues. Then you author your content in VS Code. Not GitHub, but it's Microsoft. There's GitHub code spaces. You can do that. Version control, hey, GitHub. CI/CD pipeline, GitHub Actions, static site generator, DocuSource. If you really want to go hard on GitHub, you can use their built-in Jekyll support. I don't recommend it. And then hosting platform, GitHub Pages. But there are lots of different options, all the same. That's every step in the hop of publishing your content, from the initial request to publication. Now, while the current pipelines have a lot of benefits, they also present challenges because content creation is still largely manual. Yes, I know we have generative AI, I'm getting there, but it's still largely manual. There are exceptions for things like references generated from OpenAPI documents, but hey, you still have to author the content for those OpenAPI documents somewhere in the first place to generate the references, so it's not truly automated. Content testing can be really time-consuming, if it happens at all. And then, when was the last time you did content freshness checking on your docs? I'm going to guess never, despite what some people claim. Maintenance can be significant, and especially for large documentation sets, it's really easy for one broken doc to cascade into a whole series of other broken docs, one after another falling like dominoes, and it's a miserable experience, and none of us want to deal with it, but guess what? That's what we deal with every day. And we end up with this maintenance nightmare. If you maintain docs of any sort, you know this pain. It ends up with us frustrated and our customers having lost trust in our products and our docs. And we don't want that. And the timeline you see up here is optimistic. In reality, broken documentation often goes unnoticed for weeks until just the wrong customer finds out that it's broken or wrong or slightly outdated, and then it becomes the burning fire that you have to address right this moment. But what if the docs could heal themselves? What if they can fix themselves? What if your docs pipelines could proactively propose fixes, create pull requests, and even update itself while you sleep? This isn't science fiction. It's happening today. Self-healing documentation uses agentic AI, I told you I'd get there, that can perceive aspects of its environment, that is your documentation and your products, and reason about the issue, yes, I'm using the term loosely, and take corrective actions. Think of them as intelligent assistants that never sleep. Let's talk about the pieces of this tech stack and what makes it work. First, content generation tools. This is the one that we are most familiar with today. These tools help writers, content authors of any stripe, create initial drafts of supplementary content or edit existing content to some degree. They can take inputs like documentation requests, planning documents, API designs, and then spit out whatever needs to be spat out. It's not always pretty. It's rarely accurate. It's rarely good, but it's a starting point. And these tools are getting better with time. Now, I'm not just talking about the general purpose large language models. I'm talking about specialized tools intended for authors. If there's anyone from writer here in the house, thank you. These tools, to be executed well, need to take into consideration the constraints of our technical content that we are authoring. And content generation flow, well, you got a doc request or an API spec, you throw it through the generation tool, it drafts the documentation. Human review, guess what? Human says that isn't good enough. Go back, do some revisions until it is good enough, and then guess what? You get to publish the content. And for those who like even prettier visuals, it's the same basic idea. You can take the same technical inputs, and then you can produce all sorts of different kinds of outputs based on what you need. And I know this works because I built one. Verba GPT is an internal Skyflow-only tool that we use to dramatically reduce the time to first draft. I built it over a year and a half ago. We use it on a daily basis. It reduced time to first draft by supplying planning documents and specifying outputs based on templates from approximately 2 days to 5 minutes. Again, it's draft. It's nowhere near final. I usually tear it apart and rewrite it to get where I'm going, but it solves the blank page problem and it helps accelerate not just me, but everyone across the entirety of the company, enabling everyone to more easily contribute to documentation while keeping standards higher than they used to be. But if this is so easy, why haven't we all adopted this already? Well, here's the thing. We're starting to, we're inching there, but it's not easy because good content generation needs to be accurate. And the only way to be accurate is to have known good context to refer to. When you're creating a new guide based on features that already exist, that's great, that's fine. But when you're working on net new documentation for a net new feature that has never existed before in your product and is nowhere in your tool's context, guess what? You have to supply that context. And that's the hard part. And if we get into the technical end of things, that also means that we need retrieval augmented generation, which is hard to get done right in the first place, and the output has to be properly structured, and there are all sorts of problems with it. But we're getting better. And this is the bit that we're most familiar with and comfortable with already. But it's only the first piece to the puzzle. Existing tools that we've already got, I mentioned Writer earlier, but we've got GitHub Copilot, we've got Cursor, there are all sorts of tools out there that can be adapted or are made specifically for technical content creation. They exist, they're great, use them. Now there's a second category of tool that's really important for this tech stack, and that's linters. Yes, I get excited about linters, I love Veil. Linters have been around for a long while, but they're just as indispensable as ever. Whether you're using Veil for prose linting, whether you're using something like Redocly or Spectral for OpenAPI linting, or what have you, they make sure that our content is structured correctly and that it follows the rules that we want it to follow. And guess what? It's really straightforward. Once you have it configured and set up with the rules that you want, you pass your content into the linter, it spits out results. You get to take action on the results if you so choose. They're fortunately the easiest of all of these tools to use. They're already very established and lots of them have IDE integrations already. If you're not using them today, you should really take a look. They are very mature at this point. And I know this because I use them. As I mentioned, we've got Veil, we've got Markdown Lint, Redocly, Spectral, Commit Lint, and I also built one myself. It is highly experimental, but I built it all the same. It's called Doc Structure Lint, and the purpose of it is to be able to take or define structures for documentation topics, and then validate that the markdown you pass into it adheres to that template. Ambitious, I know. It is in alpha. If you want to look at it and tell me how bad parts of it are, great, let me know. Topic number 3, content testing. Content testing tools embody the docs as tests philosophy. Yes, I'm the guy that wrote the book that was up there. If you want me to sign it, cool, let's do it. But they treat documentation like not just code, but as literal tests, as testable assertions or statements about your product behavior. That way, they can run these tests against your product to validate that what you said is right. That way, you can have trust in your documentation and that it is accurate when your users go and read it and try to use it. Now, I've already talked about linters. Linters are great for validating syntax or validating structure. I'm not talking about that here. I'm talking about validating that the procedures can be executed as written by the end user. It's an entirely different beast. And the testing flow looks something like this. You author some content, you push it into version control, runs through your CI/CD pipeline. Sometimes you need to build it first, depending on how your testing infrastructure is set up. But then it actually will, if you have a web-based product, spin up a web browser, navigate to your product, attempt each and every procedure that you've documented, and let you know if it fails. If you have an API-based product and you have an API-based workflow that you've documented, it will try to execute each and every API call that you've documented to make sure that the entire workflow can be executed correctly. And that way, if it can't be, you find out from your systems before a user finds out and yells at your customer support. As I mentioned, you can test UIs, you can test APIs, you can also test CLIs, because there are a whole lot of those nowadays. And you can also test code samples for SDKs. You can test literally any user interface. Now, I'm getting a little bit ahead of myself, but some of these tools can even go so far as to not just fail silently, but they can create a GitHub issue. They can ping you via Slack or whatever else you so choose as your notification mechanism. And I know this because I built one. Doc Detective is a tool, open source tool, I might add, that automates documentation testing. It checks your documentation against your product interfaces. It makes sure that all of your UI strings, all of your button labels that you claim exist in a particular way, down to the capitalization of them, do in fact exist. That your screenshots are up to date. And if they aren't, it'll take new ones for you, so you don't have to do it manually. And it does a whole heck of a lot more. It helps you catch the errors that might otherwise slip through the cracks and help you make sure that your documentation is accurate and reliable. And content testing tools are powerful. They're wildly powerful, but they're not without their own challenges because they require a deep understanding of the product interfaces that they're testing against, and they need to be able to interact with those interfaces programmatically. And while this is doable, there is a learning curve. It's not only a new tool, it's a new kind of tool for our industry. And testing is not something that has traditionally been in the writer's purview. So it's not something that as many people in our community are already primed to tackle. And there are more tools than Doc Detective. We've got Azure Innovation Engine. We've got Jupyter Notebooks, which are inherently testable, along with RunMe and the newer Arazzo specification that was released by the Open API Initiative last year. Not a whole lot of tooling that supports that yet, but it's coming. Some is already out. Now, with all of those pieces in place, we build to self-healing systems. Content self-healing tools represent, in my view, the cutting edge of documentation automation. They promise to handle routine maintenance of tasks automatically or semi-automatically. They allow us to focus on the more creative aspects of our jobs. Self-healing tools are almost exclusively going to be agentic AI systems that take in a lot of different contexts from a lot of different places and reason about what the appropriate next steps and resolutions are. And agents are being actively developed and deployed today. And that's what a self-healing flow might look like, my friends. Yeah, it's a lot more complicated, but you have the healing agent at the center. And as you can see, it can take inputs from validation tools. It can take inputs from a change monitor, and then kick off research from existing documentation, collaboration platforms, system logs, linters, humans request more information, and then it can attempt to fix it on its own. And then once it has a draft, kick it off to a human for review and say, hey, does this look right? Your engineer checked something in. This looks cool. You should document this probably, without you having to do anything. Imagine a scenario where a change monitoring tool detects that a code update or a content testing tool like Doc Detective finds an inconsistency between the documentation and the product UI. The docs refer to a button string that doesn't exist. The content testing tool sends the error and the associated information to the healing tool. The healing tool receives the error and researches the discrepancy by analyzing the existing documentation and the Git history to see if this string ever existed. The tool discovers that from the Git history that the button string in the docs was there a week ago and it was changed in the code. And it notes what the new string is. The tool also discovers from Git and the system logs that a new version of the product was just released yesterday, which makes sense that the test is only failing now. And that release has the new string. And so with all of this information, the healing tool is able to create a pull request to update the documentation with the new string. And depending on how aggressive you want it to be, it could even tell you which engineer made the change and didn't notify you. And I know this works because I built one and because I use them. Now, I did build one. It was the next iteration of VerbaGPT, but there are much better tools and publicly available tools that can do this today. And while the very specifics of what I just detailed might be a little bit beyond what the current tools are capable of, they're not far off. They are not far off at all, my friends. And no, they did not ask me to do this, but I am actually using Promptless, thank you sponsors, today for the Doc Detective documentation. And when I am developing new features, it programmatically picks up, hey, Manny, you just added a new feature for the HTTP request action. Let me spin up a docs PR for you. And I look at it and I tear it to shreds. And then once the feature is live, I'll go and I'll publish the docs. But again, just like with the generative AI example, it had the baseline for me to work off of. It accelerated me tremendously. It was not good enough to publish as is, not always. For smaller things, it definitely is. But for the new things, new documents, new features, that requires more of our touch. That's a higher touch point, higher focus, higher creative thinking that I want to be focusing on as a writer. The information architecture, how everything flows together. And many times it has let me know when a very small piece of documentation tucked into a cranny of the doc set needs to be updated because of a new feature and I forgot about it. So thank you, Prithvi and Francis. And as for the tools, like I mentioned, there's Promptless, there's Hyperlinked, there are a variety of other tools that are being developed. And yes, you can even get GitHub's autonomous coding agent to do parts of this for you because it can be triggered programmatically from GitHub issues. And so if you can programmatically create a GitHub issue, you can build your own flows with it. Just think on that. Now, self-healing tools offer tremendous potential, but they are also not without their challenges. They require a deep understanding of our documentation content and the product interfaces themselves. They also need to be able to analyze and interpret all of the context that they ingest from all of these different sources. And that can be a really complex task in and of itself. It's hard for humans, let alone for AI. But along with all of that, they need to be built with great intention for their purpose. If you think that the general purpose generative AI tools out there are bad at our specialty, the general purpose agentic AI tools are worse because it is a much harder task to run an agentic AI than it is a simple generative AI. And so when the simpler one has a hard time, the agentic one's going to have an even harder one, which is what makes the more specialized agents in our domain even more important. And the power of integrating all of these together is where things get really interesting, because if you pair generation and testing together, cool. You can generate content and immediately verify that it's accurate. And if it's not accurate, send it back to the drawing board and tell the AI, hey, go back and fix this until it works, please. If you pair testing and self-healing together, like we already said, if it detects an issue in production, then cool, it can give you a fix while you're sleeping. And if you pair self-healing and generation, then it gets to not just identify that there's an issue, but attempt to generate that fix in the first place. And this is what the new pipeline looks like. It's a little bit of everything coming from everywhere all at once. Yes, that was on purpose. But whether the trigger for the workflow comes from a content generation pipeline or an authoring content or a collaboration platform or from scheduled testing, the humans are in the loop. That's where I have author content. Yeah, we're the authors. I included us in here. Yes, human in the loop, please and thank you. But also content self-healing tools. But once the content has been validated as good, then it flows down the typical pipe that we've got today already, except wedged right there in the middle. We've got the content testing, just to make sure absolutely that nothing breaks before it goes live. And all of this, all of these advancements are not about replacing technical writers. They do not replace us. They empower us. They empower us to have peace of mind, to know that our content is accurate, that it is up to date, to help us get what we want produced with lower lift so that we can actually focus on the parts of the job that we want. No one wants to be sitting there dealing with bug reports when you'd rather be having dinner with your family. These tools are here to empower us, and in my experience, they do a wonderful job of it already. We get to produce better documentation more efficiently at a scale previously unimaginable. And while that means that we do have to take care to mind our mental well-being to prevent burnout, ask me how I know, it means that we get to focus on the more creative aspects. We get to stretch ourselves and learn these new tools and methodologies to better suit our purposes. And we get to focus on the strategy, on the innovation, on the user experience. When was the last time you actually got to sit down and focus on the user experience of your documentation rather than just churning out more words? Our role as technical communicators is shifting from just writers to content curators, and these tools are here to help empower that and to empower us. And to me, that is incredibly exciting. Thank you for listening. I obviously am excited about the future that we have ahead of us, but please feel free to connect with me at any point in time. I like to think I'm pretty friendly. Whether it's LinkedIn, whether it's in person, Doc Detective is open source. We accept both code and documentation contributions. And we have an open Discord server. So please feel free, join. We would love to have you in our community, and always happy to chat. Doesn't matter what it's about, anything I talked about today or anything else. So thank you. Did we have any time for questions?
Yeah, you touched on it briefly, but one of the things as a technical writer I've always hated is including screenshots of the UI.
Yep.
Because it changes without announcement.
Yes.
And it sounds like you says, well, if there's a spec change that changes the UI, then the system can be triggered to go make a new screenshot. But what if you don't have that input? Is there a way to just like proof that every screenshot that is in the documentation still is accurate to what happens in the current product?
To increase the drama and repeat the question for the recording, the question is there a way to automatically check all of the visuals in a doc set, all the screenshots in a doc set without having a trigger telling you that something changed? And the answer is yes. It's called visual regression testing. I've baked it into Doc Detective, and the way that it works is that if you run a set of tests that includes an action to capture a screenshot, then it will automatically capture a screenshot. And if a screenshot already exists at the path that you specified, it will compare the new and the old screenshots. And it will do not a hash base, not anything like that. It will actually do a pixel by pixel diff between the two files. And it'll say, hey, the new file is about 26% different from the old file, and that's higher than your approved threshold of 5%. So I'm gonna fail this step and notify you, but here's the new screenshot in case you want it, in case this isn't a bug. And then you can just save it and be on your way. And the GitHub action that Doc Detective has, there's an official GitHub action that I built, also has the ability to not only create GitHub issues upon run failures, but it can also create new PRs if there are any files that were created. And just to top the visual regression testing, there are other kinds of regression testing that Doc Detective supports, including if you make an API call, it can save the response to a file. And then it can do regression testing on that file to let you know if there's an unexpected change in the API response. Or if you run a terminal command, it can save the response of that to a text file and do the same regression testing across test runs. So that regardless of your interface, you can know that what you're telling users is accurate. And as an added bonus, instead of having to replicate those API or CLI responses in your documentation, you can just transclude them in and say, nope, this is the literal response that you're going to get from here, from this command. And if those need to be updated, the tool will do it for you.
I saw that right here and there about the presentation, but how would you go about socializing this to cross-functionally? If you were talking to an exec or somebody on the support of the marketing teams?
So there are a lot of moving pieces to this puzzle, and I suggest you do them one at a time. If there are any copies back on the counter, so I actually talk about socializing docs as tests specifically within organizations. But that strategy, really, you can apply to anything. I suggest start with the easiest task first. That's probably going to be a linter. Or whatever your leadership team finds the shiniest, which is probably going to be agentic AI right about now. And so you could probably get a linter up and running immediately and start getting feedback on that immediately and showing that, hey, there are these other tools that can help improve our docs really easily. Or if you want to go the agentic AI route, well, just go talk to Prithvi. But otherwise, as far as docs as tests specifically, because it is such a novel thing that, heck, most writers still aren't aware of it. And so our engineering colleagues and our leadership certainly aren't going to be aware of it. The best way that I have found success is don't ask, show. And so do a very small POC on a happy path in your documentation that's really critical to the user journey. And then say, hey, while I created this, I actually found like 3 bugs or, whatever your experience was. And now I can confirm with certainty that this will not break without us knowing. And then they can say, oh, you mean you're actually testing your docs like engineering tests their code? That's cool. And I'm really glad to know that that's not going to break now. I wasn't concerned about that before, but now I am. And then you can use that to very slowly snowball more support and build out your testing infrastructure as time goes on.
There is a concern with generative models and agentic models hallucinations.
Yes.
That's something that concerns you with what you're developing, and if so, how do you manage that?
So the question is, am I concerned about hallucination? Yes. And how do I handle it? The biggest way to handle hallucination is providing known good context. And that can be really hard, especially when we are developing novel features, because there is a very limited known good context to work from. But what we do have are PRDs, product requirements documents. We have engineering designs. If we're lucky, we have open API documents. But that's not it. We also have transcripts of demo recordings. We have interviews we do with engineers when we're doing our research and how the heck we're going to document this new thingamajig in the first place. You take that, great. Transcript is text. You feed it into the generative AI, and then out pops a somewhat more accurate version of what we want. We should always, 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 always be doing fact checking. We should always be verifying anything that comes out of an agentic system. But there are known good ways of reducing hallucination, and providing that known good context is the easiest and most effective way to do it. Another strategy is to run the same generative pipeline multiple times and compare results and pass the context and the newly created content into a reviewer and editor agentic system that can review the context and see if it hallucinates, like try to have the AI detect if it hallucinated anything out of that wasn't in the source context, but that gets way more complicated. All right, and I think that's time. Thank you, everybody.
Can everyone hear me okay? I'm choosing to go without a mic because there's a little bit of feedback. But I'm Justina Nguyen. I'm the head of marketing over at README. And you're probably wondering, contrary to Manny, I manage everything that's not Docs. I manage marketing. However, Docs has been a huge part of my career. And so as I've been reflecting on how I even got to README, how much I appreciate the Write the Docs community, Docs has just been a huge center of my career. So I started out as an intern at my dad's biomedical company where I assembled IFUs, which are information for users, specifically medical instructions for doctors on how to use medical devices. And I learned there that Docs and the product need to be developed together, because without that, doctors wouldn't be able to have reference material. And that reference material is super important. From there, I started working at, obviously much later, I started working at smaller startups. And what the Docs process looks like at every company is a little bit different. But at a startup, one of the first startups I worked at, Docs are your product. And so without that, developers wouldn't even be able to onboard. And really what drives a startup is that API adoption. You're really trying to see if developers can and want to use your APIs. As I started moving on to bigger companies, I realized that Docs are part of your culture. As I started tinkering, I remember and wanting to build, I remember visiting various Docs sites because that's where a developer goes first. If you want to learn how to build something, you're going to Docs. You're going to read how that API works, how to integrate it. And not just read about it, you're really learning and onboarding with that API. And the last one. My background has primarily been in developer relations, which means that I like building stuff. I like showing other people what to build. And I like learning what other people are building. And so there's an entire community that can be built around Docs, whether that's discussions. And usually the first thing when someone asks a question of how do you do that, you're usually sending them to the Docs. And so what brought me to README is I realized that Docs aren't just part of the developer experience, they are the developer experience. If you haven't heard of README, we're an API documentation platform. We started out kind of the opposite from what Manny was talking about. So we were founded about 10 years ago. And the idea is that we wanted everyone to be able to contribute to Docs. And 10 years ago, it wasn't just create a ticket, find someone who has access to that repo, fix that typo or whatever it is. And so now we made it possible so that everybody can contribute to Docs. So I'm going to talk a little bit about what the Docs process looks like at README, because at every company, it looks just a little different. So it usually starts with something like this. Hey, Ryan, how are the Docs looking? And everyone at README contributes to Docs. Whether you're a designer, an engineer, in product, support, everyone contributes to Docs, no matter where they work from. You want to do a few clicks because I have a bunch of screenshots basically of what it looks like at README when we talk about Docs. So at README, everyone contributes to Docs in various places, whether that's in GitHub or using our UI. And so usually it's a lot of hey, I want to get a review on this. Here's a branch. And people will work in either place. And ultimately, the goal is to keep those Docs updated because that is a hard task. And it's the most important task. And kind of like what Manny was referring to earlier, We really believe that docs are as important as the product. So we want docs to be aligned with product launches. So here you can kind of see that James is flipping the feature flag on for a feature for our enterprise customers. And I wrote those docs and I merged them in. And so we want to make sure that everyone can actually use and learn the feature about the feature that we just released. So right now, this is what documentation kind of looks like at README at a very, very high level for a new feature. So it kind of usually starts with a little bit of product brainstorming. This is a very high level look. I personally like to review tech specs, and usually we bring everybody in really early in that product development lifecycle. So everyone can kind of understand why we're building this product, who is it for, and can really understand the narrative and not just like the technical aspects of a feature, but the why behind it. And that's so important when you're writing the docs to really put in a story as well. And everyone has a little bit of a different take on what should be included in docs, screenshots or not, or maybe a little bit of whimsy with emojis. I personally am not super whimsical when I write docs, but everyone has kind of a different voice. The third step usually is you learn by doing. I'm a big believer that anytime you write docs or a technical tutorial, you should be able to follow those steps and get the output, whether that's building that integration, building that example. And so every doc that's written, you should be able to follow those steps. And that should be a sign of, can your customer do this? Or can someone who is knowledgeable, but maybe doesn't know what your product or company does, can they follow this and get that same output? Then we usually write a first draft of that feature, in the docs. Usually there's like editorial and technical review. Maybe it's a review from the engineer who built that feature. And then lastly, you publish that. But there are a lot of things that happen during this entire flow, which is, okay, those tech specs and those product specs are usually constantly being iterated on. Maybe we have new ideas. You can't rely on that as the primary source of truth. It's awesome that everyone at README contributes to docs, but that means that there's so many different voices. Everyone writes in a different way. Everyone has a different tone. How do you tie that back and make sure that it's consistent? Now we're reviewing at scale. There's pages upon pages. There's so many different features. We have multiple projects. How do you make sure that everything stays consistent? How do you make sure that everything stays up to date? There are also formatting discrepancies. Some people love to use callouts. Other people might not. Some people really like bullets. Other people like short paragraphs. How do you make sure that when someone visits your docs, that's ultimately your product, that they have a consistent experience? There's so much outdated info. When a feature gets updated, how do you make sure to remember to go back? What is outdated? And then ultimately maintaining that source of truth. We have a community at README, and oftentimes it's when there's a question, the answer is in the docs. But how do you make sure that that stays a source of truth, not something in someone's head that you have to go find and then type that out? How do you make sure that it's always in the docs? We recently built and are using a linter that's built into README. Now you're probably thinking there's tons of linters, but what's a little different here is the linter enables you to actually write the rules in natural language, just in plain text. So here is a quick video I took right before this, where you can define your own style guide, errors you want to catch, and warnings. What's really different is you can just write this out in natural language, right? And so what that means is you're defining what your company believes makes for good docs. And so maybe that's every single page has to have at least one example. I talk to customers who don't want to put screenshots into their docs for the very reasons we talked about today. I talk to other customers who want a video on every single page, and that video must contain something that references a demo app, or every single API reference section must include a demo app. So you can write exactly the rules out how you want them to. We also have errors and warnings. So errors is more of that objective, you're catching objective errors that you want people to fix. So here you're seeing the page linter run on every single page. And then we have an agent that can actually help you fix those errors. So you're ultimately determining what good docs look like to you, because every single company has a different standard of voice, brand, what is it that they want, images or videos. There's so many different ways that a company defines what makes for good docs. I know that video was going over, so I just wanted to show a quick what it looks like in product. So these are some of our demo apps. This is a demo project, but ultimately what it looks like is it's a sidebar that pulls out, and you're able to really define what it is that you want the linter to catch. And so it's following you in real time. And so this is kind of at the end of that big traditional workflow that I talked about, where you're polishing and ultimately getting a pair of second eyes. And you're able to do this across all of your docs. So everyone's using AI in very different ways, but I just wanted to share a quick recap of how we're using it at README and how we're using it with our docs. And so we're prototyping and iterating on ideas with AI. We're scaffolding out tech specs a little bit differently, but ultimately how we really think about AI is that there are certain things that it cannot replace, and that humans, where really humans come first, right? Like your experience and how you use that feature is how a customer is going to use that feature. Well, one of the variations. There's so many ways that a customer can use a feature, but there's nothing that can replace the way someone learns and uses your feature. Then we typically write a first draft, let AI polish that, and then now we're slowly introducing the linter, a built-in linter, as well as a docs audit. The last thing I want to give you a sneak peek on is we've been working on something called a docs audit. We pair this with the linter. So the linter is built in and it runs on single pages. And you're defining the errors and rules in the style guide. That's great that you can run them on single pages. But what a docs audit does, it actually applies it to your entire documentation site. So if you're a big company with lots and lots of features, how are you going to review that at scale? How are you going to make sure that your brand, your tone, the examples, how are you going to make sure that every single page is in line with what you feel is up to par? And so that quick video was to show you that we're building out docs audit so that folks working on docs can actually zoom out and see a bigger picture of how they can improve their docs and make it easier for people to ship docs faster. That's it. Thank you.
Any questions for Justina?
Cool.
I have one question.
Sure.
What do you guys use to run all these models on? You use like an MCP server?
Actually, so yes, good question. We have 2 MCP servers. So one, with README, you can actually generate an MCP server of your docs out of the box. And then the second one is we have our own MCP server. So if you're looking to kind of use all of this at scale, you can use README's MCP server. So there are a couple of ways that you could do that.
Our MCP server usage, both internally and externally.
Ooh, that's like the #1 question that we get. Yes, we're actually going to be rolling out analytics for that. So I think to be super transparent, there's some concerns where external usage, so people want to automatically generate an MCP server from their own docs, but they're worried that they're going to get an overwhelming amount of requests. So we're rolling out a couple things where you can actually limit and choose the specific routes that you want the requests to go to. That's one, since we've gotten so much feedback on, hey, I don't want to overwhelm the system. How can I manage this? So we are tracking that. There are I think a big part of this is there are a lot of people who are generating an MCP server out of the box. And then I think they're trying to figure out what they're going to do with it. Everyone wants one, frankly, which is why we made it possible for people to generate one out of the box by just flipping it on. I can't show you now, but yes, we are tracking it and we are actually going to be rolling out analytics for it. Thanks. Cool. Thanks. Hi, everyone. Hi, I'm Sakshi, and today I'll be talking about how docs become dialogue, AI-powered documentation assistants. So a little about myself. I am a technical writer at Tesla, and I have a background in human-computer interaction. So I'm naturally very curious about how technology interacts and how we can solve human problems. And so I'm also passionate about bridging the gap between user needs and solutions we provide. And I want to ensure technology is both usable and impactful for our end users. So today I'll share how documentation is no longer just for humans. It's also shaping how AI talks to users. As we all know, AI works by learning patterns from large amount of data and then predicting the most likely response to a prompt. Without well-structured, accurate content, it can provide confident-sounding solutions but incorrect answers. Since AI is in boom and a lot of people are using AI, so will AI replace technical writers? The answer is there's a lot of fear. If AI can write docs, so do we still need technical writers? The reality is no. The reason being AI hallucinates without structured content, and we'll get to that. If documentation is messy, AI gets confused, leaving the users frustrated. Writers are not redundant. We are the ultimate source of truth. So what do users want? Users want quick, fast answers. They don't want to scroll through large documentation, go through PDFs, Google Slides, or whatever. So to meet with these expectations, companies embedded AI chatbots directly in their digital products, and it gave relevant, fast assistance to the users. The effectiveness of these chatbots depend entirely on the quality and clarity of the underlying documentation they are trained on. Bad docs can cause bad answers. So where does the real frustration lie? I guess a lot of you would have typed something into the chatbot and it gave you a completely wrong answer, or it got messy, or it just did not give you a right answer, and that is really frustrating, right? So why does this happen? So we found out a certain things, and as I've written, docs aren't just for humans anymore. AI reads them too. So this is because after receiving one irrelevant or unresponsive answers, a lot of users, about 30 to 45% of users, abandon the chatbot entirely or move businesses to another brand. Or no, about 60% of consumers abandon chatbot when their issues are too complex or unique for the bot to handle, often due to the underlying documentation not being clear or comprehensive enough. AI systems regularly process and read vast amount of documentation to provide answers, including structured documents, support articles, and code comments. As AI adoption surges, companies are investing more and more in making documents AI ready with clarity, structure, and machine readable standards. As I said in my previous slide, AI hallucinates. So what is hallucination? Instead of giving the right workflow step, it invents instructions that don't exist in documentation. And I would like to give you a demo of that. So this is some chatbot demo that I've made. If I type in a question, how do I reset my password? It says, certainly, to reset your password, go to settings, security, enable, and 2F, whatever that is. So in this orange thing, you can see I've written, wait, that doesn't seem right. How do I add a team member? And why does this happen? Because there are long documents with multiple topics. The FAQs are static. We have documents that are unstructured. We have dead-end static error messages and scattered content across various domain or various sites. So this is after a lot of understanding and a lot of research, we found out this. Let's talk more about
writers are enablers. Technical writers, we just don't write for people, we also write for machines. So instead of giving the right workflow step, it invents instructions that do not exist in documentation. So this is where technical writers come into picture. Again, we are the ultimate source of truth. We just don't write for people anymore, we write for machines. Our structure and clarity directly impacts AI accuracy. So to solve this problem, we conducted some research. I would like to talk more about this in our next slide. So coming back to the research methodology slide, we did some research to understand the documentation, the structure of documentation to train AI for accuracy and context. So talking about task analysis, to understand more of the user journey, we tried to first understand the problem that was happening when the user was onboarding. And that is when we understood that there were a lot of gaps. We could spot a lot of gaps in the documentation. The documentation had long paragraphs. It had missing metadata. To solve this problem, we tried to do modularization, that is like breaking documentation into Q&A style. We did some content audit, like added synonyms, labels for better AI retrieval, and then we added some tags. So we tested queries with variations and adjusted until responses are consistent. I would have loved to show you the new user experience, but because of technical glitch, I cannot show. But this is kind of a screenshot, and it basically what it does is it reduces the hallucination. I cannot say it stops hallucination, but it reduces the hallucination. So here, when we ask some question and it doesn't know, it says, would you like me, I don't know the answer, would you like me to connect to the support person? And this reduces chances of AI giving wrong answers, and that is what we were looking for. So how did we do this? We started by thinking in Q&A format, like how can we break the documentation into smaller chunks. Then we started using consistent terms terms for chatbot, and we added more hashtags, metadatas, etc. Because every time a user might put in some different keywords, like some would say password, some would say PWD, some would say passcode, etc. So for engineers, we built some ingestion pipelines that kept content clean and up to date. Which they helped us by monitoring chat logs, where it was failing, where it was succeeding, by constantly developing a feedback loop, coming in, back and forth, sharing data with us. So now it is just not about writers. Engineers also build the ingestion pipelines and monitor chatbot logs. So we believe like technical writers along with engineers can help bring more clarity into the data, and we can build better AI chatbot. So what are some of the benefits of this? Some of the benefits are it provides multi-language support. This reduces friction for global users, and it is very important because we have users from all over the world. It increases context awareness, conversation guidance. We can have interactive walkthroughs. It helps in personalization. So it can highlight UI elements, show tooltips, or trigger product tours. It also moves beyond static instructions. It helps better integration with documentation, like pulls answers directly from documentation, FAQs and knowledge bases, gives proactive assistance whenever and wherever needed, and helps in continuous learning, like improves the feedback and user interactions, helps writer redefine documentation and close gaps. It helps in escalating to human support, which we were looking at, so that it reduces hallucination and helps escalate to human support. This way users would get more confidence that it goes to some human, and then we can get a better correct answer. And then finally, it helps in secure and compliance. This is especially important where we are dealing with a lot of fintech domain and fintech users because they put in large number of data which is extremely confidential. So the outcome of this is, I just go through this in short, like it helps in reduce hallucination, it's faster, it gives more accurate answers, it lowers support tickets, and it improves user experience. And then coming to our last slide, this actually helps and increases accessibility. AI brings document to users inside the products. They do not have to switch tabs, no hunting for manuals or long documentation, and have to go through static FAQs anymore. It increases consistency. Structured docs ensure AI answers are reliable and repeatable. It helps in faster iterations. Like you can say treat documentation like code, update, test, iterate, redeploy quickly, feedback loops are better, and so on. And last, collaboration. Together, technical writers and engineers, with their collaboration, we can teach AI how to talk. So AI isn't here in replacing writers, it's actually amplifying our impact. So based off this, I can say with structured documentation, we make AI more accessible, more consistent, and faster to improve. Writers and engineers together aren't just documenting process, we are shaping how AI communicates with users. You can also shoot me messages on LinkedIn if you wanted. I go by I am Sakshi Shah. So yeah, feel free to connect. If you have questions, you can ask me there as well. Thank you guys.
Hello, everyone. I'm Shreya, and I'll talk to you about enhancing documentation quality and accessibility with AI. I'll share some use cases and prompts. First, a little bit about me. I'm on the Oracle Architecture Center team. In my role, I partner with internal stakeholders who are solution architects to publish cross-product solutions and architectures to help Oracle's customers implement Oracle's products efficiently. The URL is docs.oracle.com/solutions. Overall, I have 25 years of professional experience combining curriculum, technical writing, and I've also been a manager. Outside work, I like to volunteer with environmental volunteers in Palo Alto to encourage kids to love nature science and encourage some critical thinking. I started off as an e-learning instructional designer for the aviation industry, created e-learning for pilots, flight dispatchers, and worked with clients like Airbus, Tecma Motors, Saudi Arabian Airlines, and so on. I then moved to software e-learning in Progress Software. I was hired as a curriculum developer in Oracle's Communications Global Business Unit. I moved to Fusion ERP apps, was trained on technical writing. I became a manager of a global team. I also led the accessibility program for the organization, and that explains some of my motivations for some of my use cases as to where they came from. I moved to the Bay Area. I worked for Clover. Then I rejoined Oracle in the Oracle Architecture Center team, and this was my third role at Oracle. Moving on to my use cases, I use a basic AI GPT model, which is shared within our organization's network, but it does use the OpenAI GPT, and it's approved for use within Oracle as a chat. And I'm able to benefit from it even without the use of, without a full automation in my doc workflow. So here are some of the use cases that I find it really beneficial. First one is to generate accessible graphic description files. A graphic description file is more descriptive than an alt text. It describes a graphic like a visual user would see it. A screen reader can read this description to a user. It helps me validate and format code within code blocks and saves me time. And it helps me review spelling and grammar. Moving on to the first use case. Here's an example of an architecture diagram. This is a medium complexity diagram. It has a lot of components. If I had to write a graphic description for this, I would have to type out each of these text myself. In some diagrams, I have IP addresses. There's a lot of typing and a lot of structuring and explaining to do. So I use the GPT to save me time. To show you a quick example of what this looks like, here's the actual published output. And right below this diagram is this link to a graphic description file. So this is what this file looks like. A screen reader can read this to the user. In order to generate this file, especially it saves me time when I have a lot of diagrams within the same content, or I have some really complex diagrams. Here's the GPT-generated draft on the left. It does a pretty good job. Sometimes it doesn't do a good job the first time, and I give it a few attempts. So I've highlighted some sections that I like to eliminate and manually clean up. References to directions such as left to right, above, below, are not really useful and are extra words for a screen reader to read, as are quotation marks. I can ask it or prompt it to clean it up further, or I can also continue to just do a quick cleanup myself. And here's a cleaned up version of this graphic description file. Either way, it saves me a lot of time when there are lots of diagrams and there's a lot of complexity and I'm crunched on a tight deadline. So in addition to writing content, having to write a graphic description for every single diagram actually slows me down. And this has actually made me so much faster. The next example is a slightly more complicated diagram. This is also public documentation, one of the ones that I published. It has 3 sections called enclaves. There are components within each section. There's an air gap between each of these enclaves. These are all representative diagrams. And here's the graphic description file. But what the GPT generated for me is what you see on the left, and it had a lot of brackets, left section. These are not really relevant. References to color, not useful to someone that's not a visual user. So manually cleaned up draft, which I started with what you see on the left and cleaned it up and simplified it. But it already pulled out the text for me from the diagrams. It got the labels, it got the component names. It saved me a lot of time. So I find this really useful. Moving on. This could be an example a lot of you relate to more. Since we're a cross-product team and we don't really have expertise or even access to environments for some of the content that we publish, when there are code blocks involved, the SME provides this content in various formats. And sometimes that doesn't copy over into data from the source format, like a Confluence page code block, for example. So I just asked the GPT to clean it up for me, validate the code, and then I can just copy it and paste it in data. Similarly, another example. Moving on to the third use case, reviewing content for clarity. I really think it does well in some aspects, such as active voice and parallelism, summaries. It is able to really make the text succinct. It's able to get spelling and grammar, and it's also able to pull relevant definitions from the documentation that it's ingested in our database. What it doesn't do that well is accuracy of content. It loses context. It can get too adventurous and oversimplify things. And that's where I have to back off, manually review it, go back to the source, verify that it's got it right. And it can also get confused with conflicting information from various out-of-date sources in our database that built up over time. What prompts do I use? For accessibility for the graphic description file, I ask it to write an accessible graphic description for the diagram which I upload, which a screen reader can read, and I add on without references to the position of objects. This is the most descriptive one. Most of my other prompts are very simple, and that usually works really well. I ask it to format the code block, and I paste the code. I ask it to check spelling and grammar, paste the content, and it does a pretty good job. That's all I had for today. Any of you would like to connect with me, here's my LinkedIn. If you have questions, please let me know. Otherwise, thank you.